which is, well, I guess before I do any calculus, I would really prefer to rewrite this as t to the 1/3 okay, and then I would undo the power rule here, which would mean let's raise the power by 1 and divide by the new power. But dividing by 4/3 is the same thing as multiplying by 3/4. And this is still a fairly new process to you. We've only been doing this a little bit, so you should always check with derivative. If I did the power rule to this, you need to make sure it gives you that. Okay, then I could think about what could I take the derivative of to get 2, and that would be 2t. I know it's a t and not an x because of this dt here. Now, I can't say that this stuff equals this stuff. That's not true unless I indicate that I still have to evaluate it from -1 to 1. So this piece is necessary in this step. Some people, some textbooks, the PowerPoint slide also put like a bracket over here. That one's not really necessary. I don't usually write that one. But. Okay, and then the first fundamental theorem of calculus simply says, well, go ahead and plug in 1. So that would be 3/4 times 1 to the 4/3 minus 2 times 1. Then plug in the -1. -1 to the 4th would be +1. The cube root of +1 is 1 times 3/4 is 3/4. Plugging in -1 here would be +2. So I plugged in 1 to get this stuff, and then I plugged in -1 to get that stuff. And what am I supposed to do with these? Subtract. That's just the way it's set up. And of course, sometimes the arithmetics can be a little messy here. I'm tempted to get a common denominator until I saw this stuff. And now if I distribute this, it looks like those cancel, and we end up with -4. So this question doesn't say anything about area under the curve, but since this is one of our few examples, if I was to graph this function and I only looked at x values from -1 to 1, you would have an area of 4, and it would be all below the x-axis because it's negative. Okay, how you would do this in the calculator, when you're allowed a calculator, and to check, so even if it was a FRQ and you needed to show your work or whatnot, in the calculator, you should hit alpha window. Option number 3 is that derivative thing that I showed you last semester, but option 4 says function integrate. Just like it can only do one type of derivative for you, it can only do one type of integration for you, you have to have bounds. So I'm just going to type this question in exactly like it looks, from -1 to 1 of, I'm going to use x, but really t to the 1/3 minus 2 and dt, or dx for me because I'm putting in x. You can put t's if you'd rather. Hit enter, and it gave me an answer of -4. So quick check to make sure that that's the same. So again, that's not something that you're going to do on the fly quickly unless you practice it. But it's in alpha window, F2, all the little extra stuff that they added on to these calculators from the TI-83 to the 84 are under that menu. So, okay, so I'm going to leave this up, but I want you to now try question 27, please. And I guess I can jot 27 down in case you don't have the book in front of you.